Is it possible that a single mass can exert a gravitational force? Recently I asked this question on my YouTube channel and the results surprisingly were a resounding yes. One way to put this question into everyday language would be to consider a single solitary star infinitely distant from any other star or mass and to ask, would there be a force around that single star? Let's dig in to find out. One person suggested that, well, technically yes you could, because you could consider a mass as being made up of lots of individual little masses. But of course this argument breaks down if you're external to the mass, because if you're external to the mass you could think of it as being a point source. Try breaking a point source down. Of course you can't. If you consider Newton's third law for a moment, you will remember that every force exerts an equal and opposite force acting on a different body, and that acting on a different body means that you can't have a force if there's only one body. So straight away Newton's third law tells us that no, you can't have a force if there's only one mass. Another way to think about this, perhaps easier, is just to think about Newton's law of gravitation, F equals gmm over r squared. If one of those m's is 0, clearly the force is going to be 0. Since forces come in pairs and since we only have one, there can be no gravitational force exerted by one mass. So what's going on then? One response suggested that this is where the idea of a field comes in, and a field is an area or volume of space around the mass where there is the potential for there to be a force if there is another mass. And of course they're exactly right, so well done to that person. So the answer is, just in case you're not sure, is that no, you cannot have a force if there is only one mass. If you found that video interesting, why not try this one?